Hello friends, welcome to the presentation on successive differentiation. I am Dr. Rajeshree. In the last presentation, we have seen the nth derivatives of standard functions and the examples based on the nth derivatives of standard function. In our today's presentation, we will continue with the examples based on the nth derivatives of standard functions, and also we will see the Leibnitz theorem, which is for the derivative of the product of two functions of x. We'll revise some important nth derivatives. Here, if y is x raised to m, then we have this formula that yn is m into m minus 1, m minus n plus 1, x raised to m minus n, ym is m factorial. Then if y is ax plus b raised to m, then yn is m factorial upon m minus n factorial, a raised to n, x plus b raised to m minus n. And here is the important formula, ym is equals to m factorial a raised to m. Then for 1 upon x plus b, yn is minus 1 raised to n factorial a raised to n upon x plus b raised to n plus 1. For log x plus b, we have yn is minus 1 raised to n minus 1, n minus 1 factorial a raised to n, x plus b raised to n. Then for e raised to ax sin bx plus c, we have yn is r raised to n, e raised to x sin bx plus c plus n theta. For r, square root a square plus b square theta tan inverse b upon a. And for e raised to x cos bx plus c, we have yn is r raised to n, e raised to x cos bx plus c plus n theta. For r is square root of a square plus b square, and theta is tan inverse b upon a. Next example, find 100th derivative of x plus b raised to 100. As I have shown the formula for ym, if n and m are same, so if y is equals to ax plus b raised to 100, and we have to find the 100th derivative, we have the formula m factorial into a raised to m. So here y 100, it is equals to 100 factorial a raised to 100. Next is, if y is equals to cos square x into sin x, then find the nth derivative of y. Here the function is cos square x into sin x. We'll rewrite this function. We'll make some adjustments. So we'll write cos square x as cos x into cos x, and here we'll multiply it and divide by 2. So it becomes 2 into sin x cos x upon 2. And if we take together 2 sin x cos x, we have the formula sin 2x. So sin 2x is 2 into sin x cos x. So we'll rewrite it is equals to 1 by 2 sin 2x cos x. Now we have the formula sin a cos b. It is sin a cos b, it is 1 by 2 sin a plus b plus sin a minus b. Here a sin a cos b. So a is 2, b is 1. So firstly it is sin a plus b. So it is sin 2 plus 1. So sin 3x. Here by mistake the sign is minus. It should be plus, and plus sin a minus b. So sin 2 minus 1. So it is sin x. So it is 1 by 4 sin 3x minus sin x. And we have the formula of sin x plus b. So it is a raised to n and sin x plus b plus n pi by 2. So the answer is 1 by 4 3 raised to n sin 3x plus n pi by 2 plus it is sin x plus n pi by 2. Next and important, we'll start with the Leibniz theorem. Leibniz theorem for nth derivative of product of two functions. And here is the statement. Let y equal to uv, where u and v are functions of x possessing derivatives of nth order, then the nth derivative of y is given by yn is equals to uvn, which is equals to nc0 unv plus nc1 un minus 1 v1 plus nc2 un minus 2 v2 so on, plus ncn u vn, where ncr, it is n factorial upon n minus r factorial into r factorial. So it was the statement. Now we'll start with the examples based on the Leibniz theorem. So here example, if y is equals to sine inverse x, then show that 1 minus x square into yn plus 2 minus 2n plus 1 into x yn plus 1 minus n square yn is equals to 0. So solution is here. If y is equals to sine inverse x, we'll find the first derivative, which is y1 is equals to 1 upon square root of 1 minus x square. We'll square it. So squaring on both the sides, we'll get y1 square, which is equals to 1 upon 1 minus x square. Then we multiply y1 square and 1 minus x square. So it is equals to 1. y1 square into 1 minus x square is equals to 1. So we get the equation here. Now next step is differentiating with respect to x. We'll get, now see, we'll apply UV rule here. So here we'll take firstly derivative of y1 square. So it is 2y1, derivative of y1 is y2 into the second term as it is 1 minus x square, plus we'll keep y1 square as it is and into the bracket derivative of 1 minus x square. So it is minus 2x, and right hand side is a constant one, so derivative of 1 is 0. So after differentiating with respect to x, we'll get this. Now we can see that 2y1 term is common, so we'll take 2y1 out of the bracket, and into the bracket we have y2 into 1 minus x square minus x into y1. And now as we know that 2y1, it is a non-zero quantity, so 2y1 not equal to 0. So here we can write bracket is equals to 0, and that bracket is y2 into 1 minus x square minus x into y1 is 0. So now we are in a position to apply the Leibnitz rule, because here we have the in this equation we have the term included y2, and we have to find the equation in terms of yn plus 2. So here if we apply the Leibniz rule, here y2 will become yn plus 2, because we are going to find the nth derivative. So now you see how we can apply the Leibniz rule and get the final answer. So now see, by Leibniz rule, see first y2, here we are applying the Leibniz rule, so it becomes yn plus 2 into second term as it is 1 minus x square, plus next term is nc1, so nc1 is nc1 un minus 2, so here it becomes yn plus 2 into v1, so derivative is minus 2x. See, we are finding all these calculations with the first term y2 into 1 minus x square. We are applying Leibniz rule to first term, and then we'll apply to minus x into y1. Now whatever we are doing, that we are doing with the first term y2 into 1 minus x square. So nc1 up to nc1 we have the calculation next, plus nc2, so it is n into n minus 1 upon 2 into yn into the next derivative minus 2x is the first derivative, next is second derivative is minus 2. So here we have completed calculations with the applying Leibniz rule to the first term y2 into 1 minus x square. Now the next term is x into y1, so now we will apply Leibniz rule to that term minus x into y1. So see here minus sign, we'll do the calculation into the bracket. So see here it is nc0, then x into, now we have u is y1, so un, so it will be yn plus 1, and x as it is, plus nc1 is n again, and next is nc n minus 1, so here yn will get, and the derivative of x is 1. So we have total calculation of Leibniz rule of second term we have done. So we'll see some calculation simplification, which term get cancelled, and now in the next step we'll get 1 minus x square into yn plus 2 minus 2nx yn plus 1. See here 2 term get cancelled, minus n square yn plus n into yn, then minus x into yn plus 1 minus n into yn. So here we'll see which terms get cancelled. So nyn plus nyn minus nyn get cancelled. So we have the answer here 1 minus x square yn plus 2 minus here for the term yn plus 1 we have x into yn plus 1 common, and into the bracket we have 2n plus 1 and minus the term of yn is minus n square into yn is 0. So we have the answer here.